Hello and welcome to this short tutorial on Disco, an app created through the EU-funded project Explore. In this video, we will highlight how to use this application and the scientific data that can be produced with it. Disco is one of 6 scientific data applications that can be found on the Explore platform. For more detailed information on its features, you can always consult the corresponding user manual. Disco provides a more effective representation of large spectral databases using machine learning algorithms. Disco uses a novel representation to map the spectra based on the dimensionality reduction technique called UMAP. This allows, for example, to allocate a weirdness score to each of the spectra, helping with identifying the spectra that are at odds with the rest of the sample. The databases used in the application are those of the Apogee stellar parameters and Gaia astrometric data. When opening the application, you can find several panels that help create the desired outputs. In the middle is the main visualization panel, which shows the data. In fact, it does not show every individual data point, but instead uses a rendering technique to avoid slowing down the application when large amount of data is displayed. The main visualization panel can be controlled using the drop-down menus located on its left-hand side. The top one allows you to select the main dataset to display between the Gaia and the Apogee data. Below, you can choose a parameter space to explore the data, either by selecting a well-known predefined parameter space listed in the plot type menu, or by freely selecting the axis using the x-axis and the y-axis drop-down menus, respectively. Finally, the data points can be colored according to one of the variables listed in the color by drop-down menu. Selection is performed using the box select tool located in the toolbox right above the main visualization panel. Since not all of the data is displayed, you might prefer to zoom in the region of interest prior to selecting the data with the box select tool. Once the tool is released, this will automatically focus on the region of interest and highlight the selected sources on the main panel. If less than 100,000 sources are selected, a list of their Gaia IDs will appear at the top of the selection panel, which can be found at the right-hand side of the main visualization panel. Below this list, the number of selected sources is displayed, as well as the boundaries of the selection box in terms of the current X and Y axis. Below this, a button allows you to display the average spectra of the selected sources. This button will display loading while the average spectra is computed, and the spectra will be displayed under the main visualization panel. We stress that displaying the average spectra can take several minutes depending on the number of selected sources. Finally, at the bottom of the selection panel, you can find buttons to save the selected data and the average spectra as CSV files. The name of these files can be changed using the text box available at the bottom of the selection panel, where a button can also be found to reset the selection.